Um, it's a review of a penny drop, and it's basically talking about an object in free fall. Okay, and the definition for that is any object that's falling under the influence of gravity is considered to be in free fall. So if you're a skydiver and you're falling out of an airplane before you open your parachute, that's when you're in free fall. Once you open your parachute, you're not in free fall anymore because you've got a parachute, which is slowing your descent. But before you do that, you're in what's called free fall. So any object that's falling under the influence of gravity is considered to be in free fall. So that's the only thing that's influencing the object. There's no motor or anything else doing that, okay? So this little diagram here, it's a really simple diagram. It shows a penny, and it shows it falling, and it's falling toward a floor here. And we're just going to write that down here so you can see what that is. And what I'm going to do is, I like this a lot, just for simplicity. I'm going to make the floor the origin. I'm going to call that 0. Okay, I'm going to call that 0. So when it falls, it's falling from a positive location. Okay, so if you were to make a position time graph, you would have this penny be at a positive position, and it would fall toward the origin. Okay, so that's the penny being dropped. It's falling from a positive position, a height, to the floor, which would be 0. Okay, so on the diagram at the right, we're going to show the penny falling, and we're going to write a sign. We're going to write a sign, plus, negative, or 0, and the word increasing, decreasing, constant, or 0 that best describes the position, velocity, acceleration of the penny at each location. So there are 3 locations. Okay, so this is the start of the drop up here. Okay, this is the start of the drop. And the floor is the end of the drop, obviously, right? That's the end. Okay, that's the end. So we're going to talk about early in the drop, middle of the drop, and late in the drop. Okay, we are not going to talk about the penny once it hits the floor. Once it hits the floor, it's stopped. I don't really care about that. I care about it early in the drop, in the middle of the drop, and the instant before it hits the floor. Okay, so first of all, let's talk about, well, what would the position of the penny be all the way down? Okay, well, that's pretty easy to say. Well, it's going to be positive, right? It's going to always be in a positive position, because if the floor is 0, this is always going to be positive. So the sign is going to be positive for the position. Now the word increasing, decreasing, constant, or 0, well, it's going to be decreasing, isn't it? Because the highest point is going to be here when it gets dropped. Here's the middle point, and here's going to be the lowest point, right before it hits the floor, okay? So the position is going to be positive and decreasing all the way down. All the way down, okay? It's not going to change, okay? Its velocity, okay? This is accelerating, okay? With the acceleration due to gravity on the Earth, okay? And the acceleration due to gravity in the Earth, this isn't quite true, but there's a good simplification that says it's a constant, and it's a constant minus 9.8 meters per second squared. That's a simplification, but it's a good simplification, okay? It's a constant minus 9.8 meters per second squared. So this is called little g. Okay, this is little g. Notice it's negative because the acceleration is downward toward the center of the Earth. Okay, it's an acceleration. We can tell that from the units. Okay, so any object on the Earth accelerates toward the center of the Earth when it falls. Okay, so the velocity, since it's accelerating downward, okay, the velocity of the thing has to be negative because it's going in a negative direction. Okay, it's going in a negative direction, and the velocity is going to be increasing because the penny is accelerating on its fall. Okay, the penny is accelerating on its fall. So it's falling in a negative direction, but the velocity is increasing. In fact, the fastest velocity the penny will have will be the instant before it hits the floor, right here. Right before it hits the floor will be the fastest it would be traveling. Okay? Now, the acceleration. The acceleration is, look at this number. It's negative all the way down. And It's a minus 9.8 all the way down. It's a constant acceleration, so it's negative and it's constant. Okay, all the way down. So you should be able to remember this. This is sort of like, try to memorize this if you can. But if you can't, just think it through, and I think you'll be able to do that. So now we want to calculate the time it takes for a penny to fall 0.5 meters down to the floor. Okay? Now, so what are my givens? Well, first of all, I'm going to write my givens. Okay? The first given is the displacement is going to be minus 0.5 meters. Well, why negative? Because the displacement is downward. It's down. Okay? The acceleration is the acceleration due to gravity. It's minus 9.8 meters per second squared. Okay? The initial velocity, when I just initially let the thing go at the top, right at the time it starts to make the fall, at the very beginning, at the instant it falls, the initial velocity of an object like this is going to be 0. Okay, the initial velocity is going to be 0. Well, it's asking me calculate the time. So what does it want? It wants delta t. Okay, so what am I going to use to solve this? Well, I've got 3 equations, and I want an equation that has these 4 variables but nothing else. Well, there's one equation that does that, and that's the displacement equation. So it's displacement equals VI delta t plus 1/2 A delta t squared. Okay, now I'm going to simplify this. Delta t, I'm going to substitute first, and then I'm going to simplify. Delta t, I'm going to leave out the units to make it simple. Okay, VI is 0. I don't know delta t, so I'm going to leave that delta t. Plus 1/2 times A minus 9.8 times delta t squared. Okay, let's simplify that. Okay, I'm not going to carry it all the way out, but this is 0. 0 times delta t is 0. Okay, so I can get rid of that right away, right off the bat. That's gone. 1/2 times minus 9.8 is minus 4.9. So let me simplify this. Minus, whoops, I want to go back to red. Minus 5, or sorry, minus 0.5 equals, okay, 1/2 times negative 9.8 is going to be minus 4.9. This is 0 times delta t squared. Okay, so now I'm going to divide both sides by 4.9. Okay, I'm going to do that, and then I'm going to take the square root. Okay, I'm going to take the square root. And if I go through all of that, I'm not going to show the math because I don't have a lot of space and I don't want to go through all that, but I'm going to divide by 4.9 both sides, and then take the square root. Delta t is going to equal 0.32 seconds. So that's the time it takes for a penny to fall 1/2 a meter to the floor from the table. And the one thing I think you can add to this is that this assumes there's no drag due to air. Okay? Okay.